We're now going to begin our coverage of the built-in functions. So these are all of the functions that are available to use immediately in any Python program. So the official documentation lists all of these built-in functions. I've brought up this page over here, and you can see this entire list right here. So this is the official documentation. There's quite a few of them. We will not be covering all of them in this chapter. There's just too many of them to cover. Some of them are a little bit more advanced or just very rarely used, but we will cover some of the more, obviously the basic and fundamental ones and the most important ones. If you go on this page and scroll down, you will get some documentation about each and every one of these functions. There's not always a good example, but regardless, there is still some information on this page that you can find useful. All right, let's go back over here. One thing before we get started is that all functions return an object. So that means whenever you call it, there will always be something that is returned and something that you can assign to a variable. So let's take this little bit of code. You can always do something like this where you call a function and then have an assignment statement and assign the result to some variable. In this case, it is A. So some functions don't look like they return anything, and a lot of times we won't make the assignment. So we won't actually even assign what's returned to a variable name because the function returns none. So the object none is basically nothing, but it's still technically an object, and it is actually returned. So just to keep that in mind, that all functions do return an object. All right, so we're going to begin with the math functions and cover those in this video. So there's a whole set of mathematical functions that are available to you right out of the box, and we're going to cover those beginning with abs over here and just work our way down. All right, so abs just stands for the absolute value. It takes one argument and it will convert it to the absolute value. So that's what will be returned. So let's just say we have negative 75 and we call the absolute value. It will return 75. It can be a float, doesn't matter. That's fine. Let's put another cell in here. And if we put a positive number, that's fine too. It'll still run. It just will keep it as whatever it was. All right, so that's pretty simple. Now, if you call absolute value without any argument, you'll get an error message, and it should be, it's actually telling you exactly what happens. It says takes exactly one argument, 0 given. So we gave it 0 arguments. We have to give it some argument. Now, if you give it an argument that's like a string, say the string Python, you will get an error. It says bad type, so it doesn't take strings, it takes integers and floats. Okay, moving on. Divmod, this is not used too frequently, but it's still pretty easy to use. It's an interesting function. It divides and returns the remainder of the two numbers that you give it. So divmod accepts, you have to give it 2 arguments. And so let's just say, 59, 7, something like this. So you have to give it 2 arguments. And what it will return, it'll divide them. So how many times does 59 or 7 go into 59? That looks like 8. And then it'll return the remainder. So 8 times 7 is 56, which will be remainder 3. So it should give me 8, 3. So pretty interesting. Let's do another one. Let's do, say, 17, 4. So this 4 goes into 17 4 times, remainder 1. Let's just do one more. Let's just do one that's evenly divisible. So hey, about 4. So we have 5, remainder 0. So this object over here we have not talked about yet. This is a tuple. It's similar to a list. It just contains, a sequence of values, just like a list contains a sequence of values. We'll talk about tuples in an upcoming module. All right. So pretty interesting. It returns 2 objects. You give it 2 and it returns 2. So you can actually get the same result without using divmod. So hopefully you know how to do this. So let's do the first one, 59 and 7. So if we do integer division, that'll give us the first one. And I'm going to put a comma here to make it a tuple. And then if we do 59 modulus 7, we'll get the other one. So the name is actually telling you exactly what it's doing. It's dividing and it's doing the modulus operator. So it's doing integer division and modulus division. So this is the remainder. You can press Shift Tab Tab and you should get, it tells you exactly what's happening right here. So integer division and then modulus division. So that's what we did over here. All right, moving on. The min and max methods. So these are also descriptive names. These take the minimum and maximum of an iterable. So you need to have an iterable first. And actually, you can use these without an iterable, so that's not entirely true. So let's just make an iterable, say a list of different numbers over here. Okay, so we created a list, A, with a bunch of different integers. So the min, the way it works is you have to pass it in an iterable. So min, pass it in that iterable. A, I've created a list, A. And that works. It gives me the smallest number, -89. Max, it works the opposite way, and it returns the maximum, which is 200. Now, interestingly, min and max work with strings. So a string is an iterable. So if I say Python, it'll find the lowest letter, like this. Max, same thing. If we try to do something like zebra with a capital Z, you might be thinking like, why isn't Z capital? Well, it uses Unicode code point, so you'd have to remember that uppercase letters are actually lower than lowercase letters, which is why it returned an R and not Z. So if we made the Z lowercase, then it would be the maximum. All right, now there's another way to use min and max. So you don't have to have a list. What you can do is you can pass all of the items you want to find the min or max of as an argument. So you can say, all right, 20, comma 50, comma negative 80, comma 99, and press Shift Enter. Now this looks, you might be thinking, well, isn't this a list? No, this is not a list because there's no square brackets on either side. I'm passing them in individually as arguments. And the way this function works is that you can pass in any number of items as an argument. So, and it'll work with max as well. So just copy and paste this, works the same. So min and max work the same way. Now, let's just say you have a list that is of mixed types. That means we have, I really meant to say like have a string. So 9, comma Python, comma 20, comma 30. If I try to take min of A, it's going to try to find the minimum, but it can't compare a string with an integer, so you will get an error. All right, let's move on to the pow function. So this takes the power, it raises the first argument to the the power of the second argument. So pow for power, and you have to give it 2 arguments here. So let's say I want to raise 3 to the 4th power like this. So that's just 3 times 3 times 3 times 3. This is also the same thing as just doing 3 exponentiation operator 4. So basically the same thing. So it takes the first one is the first part of the exponentiation or the base, and then the second is what it is raised to. Okay, so that's pretty simple. Pow. Let's move on to the round function. So the round function rounds a number to the nearest decimal. So again, this takes 2 arguments, a number to round, and then the number of decimal places we want to round to. So typically we're rounding numbers that have decimals. So let's just say 145.87395, something like this. And we want to round this to, say, 2 decimals. So we want to cut off these. We just want to round it over here. So hopefully you remember your rounding rules. 145.87. Interestingly, you do not need a number over here. And if you don't do that, it'll round it to the nearest integer. So that's by default. If you press Shift Tab Tab, that's how you get the documentation for all of these functions. It says round a number to a given precision in decimal digits. So you put the first argument is the number you want to round. The second one is the number of digits, and it'll make the rounding. So another thing that you can do here is something that's not quite obvious, is that you can round it with a negative number. So let's say -1. What this will do is it'll round it to the nearest tens place, like this. So the nearest tens is 150. So that's pretty cool. If you have a much larger number, let's just put in a bunch more numbers. And let's just say I want to round it to the nearest 1,000. I'll put a -3 here, and it will round it to the nearest 1,000 like that. Okay, so that is the round method. We have one more method for our mathematical methods, and this is the sum method. So this is how you can sum up an iterable. It's not quite like min and max where you can give it just comma-separated arguments. It doesn't work like that. So you have to give it an iterable here. So here is an iterable, and then to sum it up is very simple. You just pass in that iterable into sum like this, and you can get the total like that. Now, you can place a list in here like this. There's nothing wrong with that. See, this is a list. I've defined a list in here, and that is okay. So you don't have to assign the list to a variable first. You can place the list immediately inside of the sum function. All right, now, let's say you want to have a sum of, some numbers. It doesn't matter. But let me do a simpler number. So say we have 8 and 9. So that would be 17, right? Now, if you press Shift Tab Tab, you can see this. There's a start value over here. So by default, the sum starts at 0. That's what you would expect, but you can have it start at anything you want. So let's just say we start at 100. So here it would be 117. We can have it start at a negative number, maybe -100, and return that. Okay, so just a different way, just another way to change the functionality. So that's what I was talking about. Arguments can change the behavior of your functions. All right, so that does it for all of these mathematical functions that are built into Python.